So this is the second video in the SC14 topic, and it is on atom economy. So I've written what atom economy is. So the atom economy of a reaction is the percentage of your reactants that are converted into a useful product. And I've got a formula for it just below. So you get the formula mass of your useful product, the product that you are actually trying to make, and you divide it by the formula mass of all of your reactants and you multiply it by 100. And what atom economy is concerned with is how many of the atoms from your reactants end up in the product you are trying to make compared to how many atoms from your reactants end up in a useless side product that you are not trying to make. And this becomes really important when you're doing reactions on a really large scale because they're much more expensive to carry out. And if lots of the atoms from your reactants are being wasted, then that's not going to be a sustainable or economically viable process. So again, the easiest way to look at this is just to look at a few examples. So ethanol, which is the alcohol in alcoholic drinks, can be made in two different ways. The formula for ethanol is C2H5, and one way of making ethanol is by reacting ethene, which is C2H4, with steam. Steam is obviously just water, H2O. When you carry out that reaction, you will see that you are only making one product. The only product you are making is ethanol, the product you are trying to make. Nothing is wasted. And when you're only making one product, you have got a 100% atom economy. And we can work this out, okay? It says here the atom economy is always 100% if you're only making one comment. But I can use this formula to show you that. So the formula mass of my useful product is going to be the formula mass of ethanol, which is going to be 12 times 2 plus 5 plus 17, which I'm going to do on my calculator, is going to be 46. That's the formula mass of my useful product, divided by C2H4 plus H2O. I know the formula of mass of water is 18, and then my C2H4 is going to be 12, and 12 is 24, and 4 is 28. And then I'm going to be multiplying this by 100, so I end up with 46 over 46, which gives me 100%. Okay, I've got a 100% atom economy because I'm only making one useful product. However, there is another way that ethanol can be made. It can be made by fermentation of sugars such as glucose. This is a biological process. And in this case, I'm starting off with glucose, C6H12O6. And you can see again that I am making ethanol. So this is my desired product. C2H5OH is my desired product. And I make 2 molecules of C2H5OH. But I'm also making 2 molecules of CO2. So carbon dioxide. When I'm calculating the atom economy of alcohol this time, it's going to be the formula mass of my useful product. So again, that works out as being 46. I am making 2 molecules of ethanol. And I know that when we were doing the moles topic before, I said you never use the big numbers when you are calculating formula mass. But when you're doing the atom economy, you do need to take into account the big numbers. So I'm going to work out my formula mass exactly as I always did and get 46. But I do have to take it into account that I am producing 2 molecules of ethanol for every 1 molecule of glucose that I start with. So I'm going to take my 46 and I'm going to multiply it by 2. Then I get the formula mass of all of my reactants. So glucose works out as being 180. I'm not getting the formula mass of CO2. I only need the formula mass of my useful product. CO2 is not what I'm trying to make. So you might say, how do you know which one is useful? You'll be told in the question, you're trying to make ethanol. That's your useful product. You are not trying to make CO2. So you're going to ignore the CO2 this time. And what you're going to get is 92, okay, from your 2 molecules of ethanol divided by 180, the formula mass of your glucose, multiplied by 100, and you get 51.1%. So by making ethanol this way, you only have a 51% atom economy, okay? So that means in the first reaction, every atom in our reactants ended up in our product. We had 100%. In the second way, of all of the atoms that I'm starting with, in my reactants, only 51% of them are ending up in my useful product. The other 49% of the atoms in my reactants are ending up in a side product. So again, that's not as sustainable. You end up with a lot of waste. So that's what we're concerned with here. I've got another example below, which we'll have a look at. This time I'm looking at copper. So, I've got two different ways of extracting copper. So I've got copper oxide reacted with carbon. We would have seen this reaction back in CC11 when we looked at extraction of metals. So it's reduction with carbon. I react my copper oxide with carbon. Carbon is more reactive than copper, so it takes copper's place, and we end up with carbon dioxide and copper by itself. You're trying to extract copper. That is your useful product. Calculate the atom economy. So your useful product is copper. You've just got one copper atom, so it's 63.5. But again, you are producing two two equivalents of copper each time. So you're going to be multiplying that by 2 and you're getting 127. That's your total formula mass of your useful product. You need to get the formula mass of all of the reactants. So I'm using 2 equivalents of copper oxide. So I find the formula mass of copper oxide and I multiply it by 2. And then I've just got 1 atom of carbon there. So that's going to be plus 12. So in total, I've got 171 for my reactants. And then it's your useful products. So copper over your reactants as a percentage. Again, I'm not getting the formula mass of CO2. It's not my useful product, so I can ignore it. Okay, so essentially, you're just getting formula mass and then getting percentage. What you do need to remember is that this time you do need to pay attention to those large numbers. Okay, and this tells you that out of all of the atoms in your reactants, 74% of them end up in your desired product, whereas the other 16% are wasted. You can then look at a different method of extracting copper. So you can also extract copper from copper sulfide using oxygen. And again, you'll see that this process, you end up with pure copper. And we're going to get the atom economy of this process. So again, my desirable product, or my desired product, is copper, formula mass of 63.5. There's no big number in front of copper this time, so it's just 63.5. I look at my reactants, I've got copper sulfide, so I find the formula mass of copper sulfide and I'm adding it to the formula mass of oxygens, the formula mass of all of your reactants, and I get that as a percentage and I see that it's only 50%. So if you were in industry and you had the choice between these two reactions to extract copper, atom economy is one of the things you'd be considering. It's not the only thing you'll consider, but it's one of the things that you will consider. And you can see that this reaction above is far more favorable, as more of the atoms in your reactants are in your final product. Less is wasted. Okay, they also show that there's more than one way of making a particular product, and when deciding which reaction to use, you're going to be considering the atom economy, but you're also going to be considering a few other things, such as raw materials. So you can see here that in one reaction, I was starting with copper oxide. In one, I was starting with copper sulfide. So you need to look at which of those raw materials is cheaper, which is easier to source. That's going to be something you'll consider. Atom economy, you'll consider. Energy consumption. So if I had to heat this reaction to a really high temperature to get it to go, and if this one didn't have to be heated at all, well then that would go in this reaction's favour. If you don't have to heat it to high temperatures, it's going to be a lot cheaper. And the rate of the reaction, how quickly the reactions take place, obviously the quicker the better, and then the purity of the product. So because you're producing copper and carbon dioxide, that carbon dioxide gas will just dissipate into the atmosphere, so you're left with the pure copper. In some cases, you end up making a product that then has to be purified, and again, that takes time. So I've got an example here of back up to the alcohol reaction, and we've got a table that compares the two different ways to make alcohol. So you've got fermentation and you've got the reaction of ethene with steam, both of which we looked at up here. Remember, this was your reaction of ethene and steam, and this was your fermentation. So this reaction was 100% atom economy, and this one was 51.1. But again, it's not just atom economy that you are considering. You have to look at your raw materials. In fermentation, you are starting off with glucose. Okay, you're starting off with a sugar that is a natural product that is renewable. Ethene, which is something that we're going to look at in a later topic, you get it from crude oil, from a fossil fuel, and it's non-renewable. So that is something you're going to have to consider. For fermentation, really low temperatures. For the reaction of ethene and steam, you have to heat it up high and use high pressures. So this reaction, you're using a non-renewable starting material, you're using high temperatures and high pressures, so it's going to be much more expensive. They both require a catalyst, but your catalyst in fermentation is just the natural enzymes in yeast. Here you have to use a concentrated acid. However, this reaction is fast and you make one product, so you've got 100% atom economy and you've got a pure product compared to fermentation, which is much slower, and at the end you're not producing that pure alcohol, you have to distill it. So you've got different pros and cons for each. Typical exam question, they want you to evaluate the two different methods. And if you're asked to evaluate, you have to consider advantages and disadvantages for both methods and then give a conclusion. And with evaluate questions, you can argue either side of the case as long as you're giving advantages and disadvantages for both and a conclusion. So if we look at the raw materials, fermentation is using renewable and ethene, whereas the other method you're using non-renewable. So that's a tick in the favour of fermentation. Also, fermentation carried out low temperature and pressure compared to the other method, high temperature and pressure. So that makes it a lot cheaper. But on the other side, your ethene method is much faster and you're producing a pure product and you've got 100% atom economy. So it's fast, pure ethanol, the fermentation is slow. Okay, so you can consider the evidence for both and then give a conclusion, and your conclusion can coincide with either. So I've said overall fermentation is better because it's cheaper and better from the environment as it's using a renewable resource and it's consuming less energy. But your concluding statement could be overall the ethene method is better because it's faster and it produces a pure product and has 100% atom economy. So you can have either in your evaluating statement, you just need to pick a side. In class, I'm going to be setting you the following practice questions, okay, so you're based on the atom economy. They're all done the same way as my worked examples. So you're going to get the formula mass of your desired product, and you're going to be told what that is in the question. So you're trying to extract copper, that's your desired product. Formula mass of copper over the formula mass of all of the reactions, and just pay attention to the large numbers. You do need to consider them if they are present. So you're going to be calculating atom economy. And then at the end, in questions 5 and 6, I get you to do some theoretical yield from the previous video, as well as doing some atom economy. So it's kind of both of them together. So that's the work that you are going to be set in class. I'll put this on the cover, but if you do finish early, I've got lots of exam questions at the back of the booklet. So you've got the answers, so you can check your work. Make sure you're marking your work as you go along. All of the answers are at the back. And then at the very back, I've got the exam questions, and I've organised these. So I've got the percentage yields questions first, and then I've got the atom economy questions. So if you do finish your practice questions early, you can flick forward and have a look at some of the exam questions. But again, I'll include all of this on your cover instructions. Again, please message me if you don't know what's going on. You are going to be tested on all of this in your end of year summer exam, and when I come back, we're not going to have the time to do all of this again. So it's really, really important that you are keeping up, and just message me if you need any help.